It's okay?
Okay. Yeah, let's go.
Yeah, so good afternoon, everyone. So it's really my honor to present our journal paper, DaisyRec, benchmarking recommendation for rigorous evaluation. So these are our co-authors. And so I will follow this agenda to deliver this presentation. So recommender system has been widely applied in various application domains, such as the e-commerce and multimedia. So a very good example is the success of TikTok due to its powerful recommendation function. And also there are a lot of, there are tremendous amount of recommendation algorithms being proposed in the academia, while there is a major issue that is there are no effective benchmarks for recommendation evaluation, which leads to unproducible evaluation and unfair comparison. And actually, this can also be has been disclosed by some recent studies. For example, the results of baseline reported over the past several years are suboptimal, etc. So actually, there are a lot of factors affected the performance of recommendation during the whole evaluation process. So we define these factors as hyperfactors, and we classify them into two types: the model-independent factors and the model-dependent factors. So the independent factors refers to the factors that are isolated from the model training and optimization, for example, like the data set selection. While the dependent factor means the factors that are involved in the model design, model training, such as the loss function design and hyperparameter tuning, etc. So given these hyperfactors, we know the benchmarking recommendation is quite challenging due to the diverse settings on these hyperfactors. And most importantly, majority of the papers they do not report the citing details, so which makes the reproducibility quite challenging. And to improve this situation, and we conduct an extensive literature review by reviewing papers published at 8 top-tier conferences from the 4 years from 2020 to 2017 and 2020. And in total, we have 141 research papers. And from these papers, we extract and summarize the hyperfactors that affect the recommendation performance during the whole evaluation process. And they can be classified into the independent and dependent factors, as I mentioned previously. And now I will briefly introduce some of the factors. So the first one is the data selection. So can you imagine how many data set has been utilized in the paper collection? Okay. Actually, the answer is 18-fold. So there are 18-fold data sets in the 141 papers. And this is mainly caused by two issues: the domain diversity and the version diversity. So here the table shows the representative data sets in various domains in recommendation. So we can see we have different domains in recommendation, like the movie, the music, the book, and news, etc. And also, even in the same domain, we may have different data sets with different scales or different resources. So based on this, we propose our selection criteria. And when we select the data sets, we need to consider the popularity of the data sets, domain diversity, authority, information richness. So the figure on the right side shows the top 15 data sets utilized in the paper collection. So by applying this selection criteria, we select 6 data sets in our subsequent experimental study. And also with the data set processing, different papers have different settings. And in our study, we consider 3 views in total: the origin, file filter, and tin filter. So we believe these 3 views can comprehensively cover different data space level. And also for the data splitting, majority of the papers, they adopt the split by ratio. That means they split the training and test the data with the ratio, but the setting for the ratios vary a lot in different papers. And also some of them consider the time-step information, while others are not. Regarding to the baseline, we believe a comprehensive, comparison should select a baseline, cover these three types: the memory-based, latent factor model-based, and deep learning-based. And for the offline evaluation matrix, we believe two types of evaluation matrix should be considered. So the first group, the first three metrics measure whether the ground truth item has been included in the recommendation list, while the last three measures the ranking position of the correctly recommended items. And similarly for the model-dependent factors, so different papers have their different settings. And most surprisingly, we find out more than 13% of the papers, they directly tune their hyperparameters on the test set. So this may cause a severe information leakage issue. And to improve this situation, so finally we define some different modes to achieve the rigorous evaluation. And regardless of the modes, so they should have the same settings for the model-independent factors. Well, for the model-dependent factors, with different modes, we have different settings, and they have their pros and cons. Then to further investigate the impact of different hyperfactors, we develop an open source Python library, DaisyRec, which is available on our GitHub. And this is the picture below shows the overall framework of our library. And also we have a GUI command generator, which will be very user-friendly for the researchers. And also we have the well-prepared documentation to explain the different commands in our library. And this table shows the important findings in our study. And due to time limitation, we've only introduced several of them. So for example, we find that the denser data sets do not guarantee better performance. And also the random aware split outperforms the time-aware one. And the best parameter settings for one metric does not guarantee the others. And lastly, let's statistically discuss the impact of different hyperfactors. So the table here shows the relevant performance gap between the best and the worst results of different baselines regarding various hyperfactors. And so from the table, so we can see that the impact of the hyperfactors vary a lot across different baselines. And the data splitting methods, loss function design, and multi-optimizer are the top three impactful hyperfactors. Okay, and to benchmark recommendation based on our practical theory study and the empirical study, we propose standard procedures for recommendation evaluation. You can refer details in our paper, and also we provide the performance of SOTA baseline on the selected data sets. Okay, we have the well-prepared documents on our GitHub. So now let me quickly wrap up my presentation. With the goal of benchmarking recommendation for rigorous evaluation, we conduct both practical theory study and empirical study. And based on these studies, we create benchmarks for rigorous evaluation. And most importantly, we have released an open source library, DaisyRec, which can be used by the researchers and the people who are working in the industry for rigorous evaluation. Okay, thanks very much for your attention.
So thank you so much, Sue, for the presentation. Do we have questions? So you can either use the microphones or use Slido. Quickly. Okay, thank you very much. Since we are a bit short on time, so I will invite our next speaker.